Hello. There's my dog. Dogs. Okay. That is Bully and Blackberry. Okay. So anyway, MC10 Club Extravaganza, which is today we're looking at an animation that I've been working on for quite a while, but I left it and then I started working on it again. So then, no, the dog's barking. That was cool. That's like one of the most exciting things that happens. So I think I'll leave it, including what I'm saying right now. But anyway, okay. So now back to this. I don't know why that's displaying that way. Anyway, over here, I use a mosaic converter. So I found a GIF, and the GIF, I converted the GIF into images, these images specifically, and then I took that data in that image and I converted it to comma separated values, and then in this one I've got them all compiled into text files which resemble this. This is one of the screens required to create a globe, one frame, and then you take one. This is 24 different frames compiled into one program, which I was planning to load into the MC10. Only problem by the time I was done, and I knew it's all programmed correctly, is that it's too big. It's 24 screens, and it would take up about 50K of memory inside the MC10. So then this sat here forever because I couldn't load it in, even with the emulator settings on the expanded memory. It wasn't even enough then. So then, which is that setting that I'm talking about, is right here with the plus 40K RAM. It doesn't even work with that. So so anyway, then what I decided to do, and with the help of my wife, she's like, you need to get something done today, so so I started working a little bit more on this just to get it done, because I was going to be working on let me see here. Yeah, so what I did is I decided to go with assembly. So I wrote an assembly language file .org 20480, and I jumped to start. Now what we're jumping over here is we're jumping all over the frame data, one frame of the world. We're jumping over 24 frames of data here, and then it starts right here, right there. Then this is the old program that used to display the world, and I had made a version that did work, but it was of lower graphical quality than this is. Huh? I'm recording a video. So anyway, now this is the program that displays the graphic, and it starts here. It skips all this old basic data is just a comment, and then first I'll go through and I'll try to explain this a bit. First we load 16384 and we store that value at screen positional data. Then we load X with world, which is the first position of all this data. Then we store that information at graphic positional data, and then we clear B. The B register is cleared to 0, and then we're going to store that count at B count, which is how many. It says right here bcount tracks the current print line's length. Okay. And then there's these loops here. Then we LDX graphic, we load X with the graphic positional value. We load A with that ASCII character, and we store that at ASCII. And we load the screen, we load the ASCII. Some of these I might be doing redundantly, but you know, it was a thought process. Okay, and then we store that at X. So I didn't go back and optimize it, I just wanted to get it working. So then we load X graphic. That's the graphic position, not the screen position. And because the two increment differently, so I had to keep them as separate variables. Then I increment the graphical ASCII position, or the data position of graphic, and then we store that at graphic. And then we load the screen, we increment the screen separately, and we store that at the screen variable, positional graphic. Then we load bcount, we increment bcount, we store bcount, we load bcount, and compare bcount with 25. Don't ask me why I did all that. It's just I was having a little bit of problems with the conditional code registers, and that's why I did all that. So, but if I go back through and optimize, I can simplify a few things. But anyway, then branch less than to next W, next world in other words. So actually it's the next world's line, it's building that line. 25 codes, and then that line is done. And then we load screen here, add 7. Now that skips it because there's going to be 7 spaces, 7 green spaces. Doesn't have to be green, but if you don't do anything, you know, it's green. Okay. I'm not sure if it's actually 7. It's 6 or 7. I think it's 6. See, 25, 24. It start. Yeah, I think it is 7 spaces. And then, so it adds 7 to screen to get to correct position on the screen, stores that D at screen, and then loads it into X, because the D register is the only register that can add and subtract so nicely. So then we compare X with the end of the screen, and then if it's we branch if it's less than to next 2. Next 2 goes back and it clears B, the count, re-clears the count, and starts over on the next line. Then, now, after that, if it isn't less than, it goes to the next part. It LDAB with screen number, increments that number, stores that, store B in screen number, and it counts how many screens it's done. It's comparing B to the 24th screen. Branch if less than to set screen position. Where is that? Oh, here. If it goes to set screen position, then it loads X with 16384, puts it back at the top of the screen, stores that at screen value, and we jump back. We jump back, clears B, starts the process all over again. Go back down here. Once it gets back down here, it counts up to 24. Once it hits 24, it's not less than. I might be missing one screen, I'll have to check that. There's 1, 2, 24. Yeah, no, that's right. Okay, so then, no, that's right. It's correct, because if it went one more, it would not display the right graphics. Okay, so then, since it's not less than, it goes to it doesn't go to set screen position. It loads X with 0, and it stores X at screen number. Now the reason why it does that is because if you try to rerun it, it will think it's already done, and it won't play the 24 frames. And this is actually a ripped GIF. So okay, so now it's going to return to basic, and then so we come here, we compile our code under TASM. TASM-68-B x3 world 6 dot text world, and I'll change the name here just a little to 4, and we'll compile that. No errors. Okay. So now we'll go to here, load our binary file. We'll browse for it. We're going to load number 4, which is what I just compiled. And now I'll just go execute. And voila. Now, if I type 10, execute, colon, go to 10, then I can run this. And there we go. Now I can, usually you can hit break, sometimes it doesn't register. If it's such a tight loop, it has a hard time because it's mostly updating the screen for a lot of that time period. So you have to happen to get it when it's coming back to basic before it can break. So we'll run this one more time. Now I'm going to upload this. I already see what I mean. See, sometimes there it goes. So now I'll go hard reset, cload M, play cassette file, and I've got it written under globe. C10. If I go list, there's nothing there, but it's a machine language file. So now if you just go execute, there it is. Execute. There it is. 10. Go to. No, not go to. Execute. Colon. Go to 10. Run. There we go. Oh, that's going to be uploaded to the MC10 Club files area, along with the code, everything. TASM. You can. I don't know if I can upload that or not, but I might try. And so that's the process of converting a GIF into an animation for the MC10. Now, in order to get those graphics the way I did, I had to limit the number of graphics. I had to pick a landmass graph and a water graph. Graphic character that would match up, and the 3 colors that were the best were this orangish color that looks more like land, and then the blue for water and the black for background. And so anyway, that all worked out good. And till next time.